So beginning of chapter 7, we go into covalent bonding. So chapter 6 was more ionic bonding, and lattice energies, and positive and negative charges. This still has that positive negative charge, the electrostatics, but this time instead of there being a positive atom and a negative atom, we just have these positive centers that we've worked with before, which is the nucleus that has the protons. And then we have the negatives around them, which is the electron cloud that surrounds that positive nucleus. So opposites attract. So these two nuclei are repelling each other, so they're repelling each other. The electrons are repelling each other, so you would think that these two atoms would never come in contact with each other, come close to each other. But there's one other part of it, and that's the attraction of the electrons from one atom to the nucleus of the other atom. So you have this attraction between the opposite charges and then the repelling of the like charges. What will actually form a bond is when these attractive forces between these two atoms is greater than the repulsive forces between them. And then once it gets that bond formation, there's a certain special spot between how close or far away these two atoms are going to be. That maximizes what's called the potential energy surface between these two atoms. So you're going to get this bond formation if you satisfy this criteria that the attractive forces are greater than the repulsive forces. The two atoms that are bonded together are going to settle at a certain length that gives the lowest potential energy between them, and that's going to be the most stable place for those two atoms to reside. And there's a good picture that's a potential energy graph on there that shows the stability and the bond length, because when you know this most stable distance between them, between the nuclei of those two atoms, that's going to give you the bond length. The bond length is related to so many other variables that we're going to talk about. But let's just look at some examples down here in terms of what bond length means. Bond length is in a way associated or close to when we talk about atomic radii, when these two atoms come close to each other, but it's not exactly that. But some good examples just in the trend of the bond lengths is, so these are in picometers, but you'll have like a hydrogen, and this line is the bond. A hydrogen bonded to another hydrogen, a nitrogen bonded to a hydrogen, a carbon bonded to a hydrogen, and there's a trend with the atomic radii that go along with this. Like the nitrogen-hydrogen, the bond length is smaller, because if you remember your trend, the atomic radii of nitrogen is smaller than the atomic radii of carbon. So that trend makes sense. The absolute values of them are a little different than the actual atomic radii, but the trend is the same. So we'll talk about that trend in bond length related to bond strength, and ultimately learn more just about covalent bonding and why it happens as we continue.